Hi, this is Lois Rilo from ForgeFlow, and today I will be doing a talk on optimizing threads under a demand-driven methodology. The agenda for this talk is the following. We'll do a brief introduction, we'll then talk shortly about demand-driven MRP methodology, and then we'll go right into the thread optimization using the DDMRP methodology. At last, we'll do a small demonstration in Odoo version 14. Let's go with the introduction. Inventory planning. We can all agree that inventory planning is an integral part of the company's supply chain management strategy. Traditionally, this involves a forecast, which we use to decide how much and when to order, the quantity and dates of our planned orders. The accuracy on how good we are in this prediction and determining this when and how much will directly impact in the return on investment of the company, which makes, again, the inventory planning a really important part in any logistics company and many others. Regarding inventory, it's obviously an asset in the balance sheet, but we can say that it can quickly become a liability if we hold it in the wrong quantity or in the wrong location. In this regard, we have two universal points of inventory. If we look at this chart here, in which we represent the quantity of inventory in the x-axis and the ROI in the y-axis, we intuitively understand that we have an optimal range of inventory or an optimal point in which our ROI is maximized due to high services level, that we get more sales and we invested the least possible to obtain that. Once we link to one of the two sizes, we start to decrease or experience a decreasement of our ROI until we can reach the point in which we have too little inventory and we miss sales, we experience shortages, and we need to pay for expedites. And point B, in which we have too much inventory, we have excess of cash tied to this inventory, and this at the same time makes us compromise our resources, the capacity of them, and maybe also the space in our warehouse. Getting to this point is even more difficult in the modern world, what we call the Buca World. Buca stands for these words that we have here and describes the reality nowadays. It's a world that is volatile, the frequency and severity of the disruptions are increasing. The pandemic is just an extreme example of this, but we have a lot of floodings and many, maybe smaller disruptions constantly in our day-to-day. This also leads us to the uncertain. It's becoming very difficult to predict what will happen in the future. At the same time, we are making our supply chains more and more complex with more and more connections and participants in the whole supply chain. We have a huge web sometimes of supply, and it is also ambiguous because we have an ocean of data at our disposal in one click, but many times it's very difficult to know what of this data is relevant and what is not. All this only makes these 3 points, these 3 truths about forecasting even more true. So forecasting will start out wrong. There is always error in each forecast we do. The longer the time range, the higher the error rate. And in these complex supply chains we have now, in which we have huge cumulative lead times, this is the case. We have to predict for a longer horizon, a longer range. The more details, the more errors. We have a lot of combinations, a lot of SKUs, and do a forecast for each of them individually is really difficult and make the error increase. Also, take into account that good forecasts are defined as in a range from optimistic to pessimistic, but in traditional MRP, in traditional planning tools, we fed the MPS, the master production schedule, with precise numbers. We need a number, while we have a forecast that is wrong and defined in a range, and we enter the system a exact number that is absolutely wrong from the beginning. In this situation, demand-driven MRP arises as a way to take all the knowledge from the traditional approaches and add a little bit of innovation to adapt to this new Buca World. So it's the main focus, I have to describe it in a few words, is of this method is to plan and manage supply chains to protect and promote the flow of relevant information and materials. And one of the key things here is that it ties the order generation to sales orders, to the most accurate information and more relevant information that we can have, not to forecast. So we are transitioning from the MPS in the MRP, which is a statement of what we can and will build, to a defined capacity to build what we can and will be sold. And how we define this capacity? Well, this is the answer is the stock buffer, the DDMRP stock buffer, which is amount of inventory strategically positioned to absorb variability and to allow to respond within the customer tolerant time. So we are in this window that we can get the relevant information of the sales orders. And at the same time, it's not that we are not using forecast at all. We are still using, but with a different goal. We use it to size this range of capacity. We use it to calculate the average daily usage, which is the main sizing factor of any of these buffers. And you can see here that we have a forecast range and we translate it into a capacity range, which makes a little bit more sense in my opinion. But then how we create or generate new supply orders? Okay, for that the innovation is the net flow position, which is computed as with this formula, which is the on hand, what we have available to any order now on hand, the open supply, whatever is coming to us, new supply orders that are open and pending to be received, and the qualified sales order, which is no other thing that relevant sale orders for today's date. When we compute this on hand plus supply order minus qualified demand, we get the net flow position, and this will give us a position in our stock buffer that we have defined before. We can then have a priority and compare from different buffers that have different sizes, but this gives us a relative priority because we can translate this into a percentage of erosion in the buffer, which is there to help us. So it's a percentage of the erosion of our coverage of the demand. When we reach, it's very simple, when we reach the yellow zone, we need to reorder, and how much to the top of green. So the net flow position to the top of green will be the order amount. If we have several buffers and we need to prioritize, we just need to take into account the color first. If something is in the red zone, is deemed high priority, and then the planning priority, which is the percentage of the net flow position. Once we have these pieces, we can start to talk about how the freight optimization is solved in demand driven, because what we saw in this previous slide is for one single SKU. But what happens when we have a group of parts, which is the case of a freight? Okay, for this, in demand-driven MRP, we have the Pretie Share, which is a supply order generation schema applied to a group of buffers based on the relative net flow positions within that group. So using the net flow positions, we can compare them and have a common sense of the coverage of them within that group and the imposition of constraints or thresholds. Typical groups of parts are grouped by supplier, bar location, or group of locations using the product extractor, etc. And typical constraints can be the order MOQ, a minimum amount, fill a transportation like a truck or a container in a boat. We can have also constraints of packaging, some filling packages, multiples of quantity, etc. But how this is solved in MRP? How does the Pretie Share work? Well, the concept is quite simple yet quite powerful, and you will see with this example. Imagine we have this scenario in we have a sourcing unit at Barcelona for a given product, and the sourcing unit has a batch size that is always 10,000 units. Then we don't store these produced units in the sourcing unit, but we store it in regional warehouses, and in this case we have 3. So we have to decide how to spread these 10,000 units among these warehouses. So we have a buffer in each of them, but we don't have any here. What can happen when we try to solve this? Well, we can have too much units to allocate. If you see here, we have the 3 buffers for the 3 regions, and if we follow the logic that I explained to you before, in which we take the net flow position and move it to the top of green to know the order amount, so top of green minus net flow position gives us the ideal or the optimal order amount, which is the 100% green. We see that this doesn't add up for the 10,000 that we need to allocate. So what we can do is to find equilibrium in which we reach a similar level of coverage, and this is possible because we have the net flow position, we have the relative priority, and we can compare buffers of different sizes. So with this we can spread the coverage evenly in our web of warehouses. So we can see now that the system solved this and said that at 110% we reached the sourcing unit batch size, and we have this order amount for each of the warehouses. The other option or the other possibility is that the sourcing unit quantity is too little. Imagine this situation: we have lower net flow positions and all the order amounts add up for something higher than 10,000. In this case, we just do the same logic, but to something lower than 100%. So we don't get the full coverage in all the positions, but we have the same coverage in all of them. With this concept, let's go to a demo in Odoo. So here we are in Odoo version 14. We can see here the list of buffers. We can see the net flow position. We can see what I said, that is easy to prioritize these stock positions using the color and then the percentage. Also, for freight optimizations, we need to define the agreements. In these agreements, we can define a series of constraints that are the ones that will make the environment for the problem. So in this case, the one that I use for the example in the slides is this batch size 10,000. I defined a global MOQ of 10,000. I also asked to respect the buffer quantity multiple, and I put a maximum fulfillment of the package type, which is a maximum amount of also 10,000 units. And you can see here, well, we can create more agreements, we can apply them to one or several vendors, add a description, and the important part, we can define several constraints. And you can see we have a lot of them here, but as we need them, we keep adding more constraints. Examples: minimum price, the maximum weight, the minimum weight, filling a transportation, the minimum fulfillment, maximum fulfillment. For example, you can use boxes and say a maximum of X amount. You can set packaging multiples, respect the buffer MOQ. You can also set to respect the quantity multiple in the buffer, the procure batch, the global MOQ. You can see that the possibilities are quite a few, and you can combine them. Then the system will try to solve the problem and let you know if that's impossible. Okay, so let's see an example. I will create a new freight optimization, in this case for top technologies. My agreement, I will use this minimum price. Let me simplify it for a moment. Only minimum price. We have to reach a minimum price of 50,000. And then we can start to add buffers. And we say, okay, let's only add one. I refresh the suggestion and I add the one that is in the worst position. And then I click on compute. What we can see is that we will overstock this buffer. We will go to 250%. So we can decide, okay, let's add one more buffer. And now we can all the time compute again. Okay, this is good, but we may decide to get even better using this tool to add more buffers, and we continue adding the worst position. Now we have filled the amount, the minimum price restriction, and we can use the recommendation quantity for the buffer that gives us the 100%. This is great, but just to give you an idea, let's make this a little bit more difficult for the system. We can say that we need to respect a multiple inboxes. So has to be, the result needs to be a multiple of one box. For simplicity, I set the box for each of these pros to contain always 10 units. Now I compute, and you see how the system tried to find the closest possible solution to the 100% and adjusted the recommended quantity to be multiples of 10 because the boxes are 10 units, and we can see in the summary that this is an integer. One more example, just for you to see. We can also set a maximum of boxes. So let's say 400 boxes. We cannot order more than that. Until now we have 433. I compute again, and I get a new result, and this one is respecting the constraints. So you can see the idea on how the net flow position gives us this possibility, and the system assists us into solving the problem with the given group of buffers and the given group of constraints. Finally, I want to add a statement from Joe Orlicki. He said he's the father of MRP, and back in the 70s he wrote this, speaking when he was introducing MRP, and he said that the most significant results were achieved but not by those who choose to improve, refine and speed up existing procedures, but by those who undertook a fundamental overhaul of their systems. So sometimes you need to be brave. I take the new wave, take the new approaches that are more in line with the current scenario. Because if we keep improving all tools, we might keep improving something that is not ready for the current environment. Want to know more? Okay, we at ForgeFlow are endorsed instructors and do courses. You can check our next courses at forgeflow.com/event. You can also navigate to the Demand Driven Institute website, where you can find a lot of material information, case studies, and a lot of interesting resources. And this is all. You have my contact information here if you need it. Thanks for watching.
I'd like to take this opportunity to welcome all of our viewers to ask your questions in the chat. Until then, let's go ahead and just recap what you've talked about, Luis, when it comes to ForgeFlow. What are some applications that could be taken? I know we talked about the freight industry, but how can this be applied to other sectors and other industries?
Thank you to all the viewers. Yeah, I think for this concept that we have went through in this talk, it will benefit almost any B2B company and wholesaling, and not to any particular industry. We have implemented it in several and sometimes quite different industries, and it's always getting some benefits. So I would say that you should not hesitate, and you can also visit the Demand Driven Institute site that I commented before, and explore the case studies there. You will see them categorized by industry, and you can probably find something similar to you and what you're looking for.
Okay, great. Luis, can you tell us a little bit more about what are some future plans for ForgeFlow? Any particular projects that you're excited about?
Yeah, we have started this journey some like 3 years ago. We involved in the DDMRP methodology, implemented all these features, and we continue doing it. We just wait for new projects. We are exploring now different markets with companies in the US, in Europe, and maybe now also having some leads in Africa to implement this methodology. And we just want to keep expanding our implementation of all the concepts that we have in the methodology to our software. And yeah, to anyone interested, I can just recommend to sign to any of our events. You can go to our site, forgeflow.com/event, and check if there is something that suits your schedule.
Well, you mentioned your site, but we got a question from Victor that asks, where can we find the sites that you're referring to? I don't know if there was anything in the description, but is there a particular website that you'd like to reference for our viewers today?
For the ones I mentioned, the ForgeFlow.com for our company, also the Demand Driven Institute, altogether .com. There you will have all the information to get to know a little bit and see if you are interested. Yep.
Wonderful. Luis, unfortunately, we are out of time today. I'd like to thank you for your participation and sharing with us your best practices and some of the exciting things coming up with ForgeFlow. Thanks again to all of our audience members. Again, have a great day, and thanks again for being here.
Thank you. Thank you all.